I'm going to then again import the libraries. I'm going to instantiate the AlanaPy. We are going to use the data source class from it. I'm going to give Python my Alana token in order to access the database. There you go. It's going to give us the good sign, the connection established successfully. And excellent. So we're going to we can develop this workflow in two ways, using the UTMs or using the latitude and longitude values that we have on the well master. So we are going to get from the data source two tables. We're going to get the monthly well production and its longitude or UTMs, either one or both of them if we have. Currently on the Alana database, we have both with UTMs and we have the Loma Campana field with longitude and latitude. We're going to use the Loma Campana because both we have the paths, we have the UTMs of the paths. So we're going to see only like a square. So that won't give us, or that won't be much more of a visualization. So we're going to use the Loma Campana list of wells. We see it's close to 600 wells. So we are going to use only, I don't know, 70 wells. But to make it a bit more interesting, we are going to import. I'm going to import a library called random. I think that you are aware of it and what it does. And I'm going to use from random random choices, which it's going to random choices. Yes, we're going to access the random choices. We're going to give a list of something, a list of elements, and we're going to give these choices function an end value. How many elements, how many choices do you want from this list? So maybe, I don't know, 50. If we run it, we will have, list was is not defined. Yes, I forgot to add the yes at the end. The number k equals, okay, k equals, there we go. And we are going to get in return randomly 50 elements of those of that list. So here we are going to call it list wells random. These are going to be the wells that we're going to get the information of the longitude and the latitude and the monthly production in order to plot the latitude and longitude, and we are going to increase the value of the fluid production on the plot. So I know that if we call my API, we have here the get monthly production function. This get monthly production, it's we need to give a well name, which is a string, and we're going to get in return a list of dictionaries. We've seen how we can manage this. Let's check it out. Let's just check this well name. Let's ask Alana for the production, and we get in response this. Excellent. And we know that. Sorry, Kurt. The lights of my house went out. There you go. I'm back. Okay, so let me reshare my screen again. Excellent. Can you hear me and see the screen properly?
Yes.
Yes.
Excellent. So give me 1 second. There you go. So we need to get the well master data, the longitude and latitude here as well in this get multi-production. How are we going to do that? Well, we know, or you should know that the AlanaPy script has the get well master function that will fetch the, as the name says, the well master. There you go, it's booting, and there you go. We have all the IDs, all the well names, the spot dates, the API, latitude, longitude, and so on and so forth. But I want it into a data frame for a much more easy way to visualize it, data frame. But I don't want all the elements or all the columns in this data frame. So I'm going to select only the list or the columns that I want. In this case, I'm going to use the ID. We're going to use the well name. We're going to use the latitude, and the longitude. And we're going to get only in response to this data frame. We're going to store this into TF well master variable, and we have the well master that has the latitude and the longitude and the well names as well. And we have the get monthly production. So now we can create a very simple for loop. Well, it's not that simple because it's going to get quite messy, but you get the idea. List, we're going to loop in those list random elements, and we're going to get, let's call it we have the well master, we have this, we have that. We are going to get a response of my API, get monthly production, get well monthly production, get monthly production. Get monthly production, we give a well name, and we're going to get something in return. We're going to give this the well name of this randomly list we created. And if response, if data is in response, we're going to move to this. Maybe we are going to print we have information. And if not, else we don't have information. We don't. Maybe the wells the wells that we are printing, the wells we're requesting doesn't have information. So in this case, all of the wells have information in the database. I'm going to stop it. It was kind of to visualize how it was going to look. And in a much more neat way of put things, we're going to put here another string, no data for well. Excellent. So now we have the data coming from the from the server. Okay, so production, data df production. It's going to be equals to the my API get monthly production. Production and the well name that we want to fetch the information of the database from the database. And in order to do that, we would need as well request from this DF well master the latitude and the longitude and the well name. And so I'm going to use, I know that if we use the function lock and we give the column, in this case, where I want to access the well name, if it's equals to, I don't know, let's put another index of this list. We are going to get in response only the elements that has this well name or this column value. In order to do that, we need we are going to kind of paste and copy and paste this function here, and we are going to kind of tweak it to get the DF well location information from the well master. We know that the well it's looping, so here instead of adding the list, we're going to add the number, the name of the well, and here we should be able to see print well and maybe latitude points and the DF well location. It's a data frame, so latitude unmatched. Yes, I forgot that we only single quotes instead of double quotes. And my API is not defined. What? Yes, it's because it's my API underscore DS. And there you go. We have, for example, for this well, we have the latitude minus 38. I am seeing a thing here. The latitude, it's on a series, on a data frame form. So we're going to ask for the values. I think, no, it's not callable. So it's without parentheses. There you go. This well has this latitude. This well has this latitude as well, and so on and so forth. So this is quite changing because we're kind of randomly selecting wells from the data from the well master. Okay, so we're getting data from the server. Excellent. We have production data right now. We have the latitude and longitude. We only need to merge. We're going to calculate first from the DF. We're going to change the DF production column, the data, the date column into ED to date time of this column, the same column. We're going to only to change the data type of this column in order to visualize it way better. And why? Because we're going to use the consume value or the consume function of the of pandas. So we're going to create the DF production oil cum, which is going to be the column. I deleted this. No, it's the oil heart, and in fact we have the oil cum here. So this kind of changes the things here, but we can do Yes, we can check for the WTF date. How can we do this? Production date, consume, rate, store it. Okay, we can store. I'm going to create a data list. A list. Yes, I'm going to create a list outside this data. I'm going to list this. We're going to append to this list data a dictionary here that will have the well name, which is going to be the looping well. We're going to store as well the X, that it's going to be the DF well location, latitude, and values. But I know that this value, it's on a list form, and I want only the first element or the 0 element of it. We're going to add this as well as a Y. So instead of latitude, it's going to be longitude. What else? We want the max oil cumulative, and I know that this max oil cumulative, it's going to be the max of the oil column of the data frame. So we are going to max cumulative. It's with a double M. No, it's just with one. It's going to be the TF production oil dot max. So we're going to copy paste it, and we want the max water as well. What, if my memory doesn't lie, if it's what can, excellent. To this and this. The oil fraction is going to be the oil fraction. It's how much oil it's been produced from the, I don't know how this was calculated, but it was water fraction and oil fraction. According to this, which is quite interesting, according to this data frame, OChem and OChem underscore, the last be between the maximum. I suppose that is like that. So in order to get this, we're going to access the DF OChem column, but we're going to index locate. We're going to index locate the -1 element, the previously to the last one. And we're going to divide this under the maximum value. We're going to get as well the water fraction, which is going to be the, I'm going to use the, I forgot, yes. What come? There you go, the last one. I added two. There you go. We have the oil and the water fraction of this well. We're going to close this dictionary. I think that everything looks fine. Let's try it and see what we get in return. Printf well, and we're going to delete this. And we're going to put data equals to this dictionary list data. There you go. And we're going to put a break here to stop. In fact, we're going to put it here. Date. What happened here? Date, maybe states. Date, yes, it's here. Data. The production date. The response, where's the response? Yes, I forgot that we have here a data index. That's been part of what we're trying to standardize all the responses from the server. And I think that listing movies is not index. There's something funny here. Let me print. Yeah, production. Let's see what we get in response. There you go. Interesting. Date. I see here date. For some reason, this is the data frame. Yeah. No, I forgot to add the pandas.data in here. There you go. There you go. Now we're talking. Excellent. That's what I was missing. Okay, so now we have the correct column date. We're going to change it to date time, and there you go. Let's see. There you go. We have this data. It's well named. The latitude, the longitude, the max oil cumulative, the max water cumulative, the oil fraction, and the water fraction. Interesting that it's one here for this case. I don't know, maybe the thing here, the oil fraction was all the liquids being produced of the well, which is the last value under the sum of the liquids, which needs to be the oil cumulative and the water cumulative. And that will give you the oil fraction. The water fraction, it's the same, but instead of the, let's add here plus. I don't know why I forgot to put that, but I'm going to put the plus on the water complex. The total liquid production of this well. It's going to be exactly the same here. There you go. And that will gives us this 0.9, the oil fraction 92%, and the water fraction. There you go. Now we're talking. I forgot to add that summation there. Excellent. So now we are getting all the information that we have that we want. Excellent. So let's delete the break. And after everything is done, I want to store that. Run it. There you go. It's running. Let me calculate how much time it's going to spend doing this, and let me delete the prints. There you go. And along it's running. Let's I need Oh, there's something. What happened here? Date. Again, interesting. Maybe try. We're going to use the try function here. There we go. And if not, we are going to add an exception here. Yeah. I want to see the well that is giving me the key error here. Or okay. Yes. There we go. Let's run it again. There you go. List data. Yes, we have an error with this direction as well. That's interesting. We have another one. Okay. Okay, interesting. Let me drink some water. I'm thirsty, I'm getting thirsty. Okay, excellent. So I want to create a data frame. Let's call it full. DF PX for Plotly Express. And this is going to be equal to the concat. No, the data, we are constructing a list of dictionaries. So in this case, it's only a data frame of this list data. There you go. From all those 50 wells that we randomly selected, 50 wells, only 1, 2, 3, 4, 5, 6, 7. 7 gave errors. Why? We would need to kind of go into the detail to see what happened. We can call call here a key error. We can call it here and print it what happened here. Maybe it's because we don't have production data on the database. We're going to check that in a couple of minutes. But let's create the data frame from this the well that successfully gave us its latitude and longitude and the maximum oil cumulatives and the fraction of this. And that's why we got here invalid value encountered in double scalars, because we have here nans. Maybe we, for example, here, there you go, we have an issue with the max oil cumulative. This well most likely was just like an appraisal or exploration well and doesn't have any production. And that's why we have this nans here. We have two. We should have 2 wells with nans. I don't see the other one, but that's quite simple to delete. We can use the df drop nans in place equals true. And if we run it, there we shouldn't be having that nan problem anymore. I'm going to create the bubble map. I created a couple of things a couple of hours ago. This very simple function or a line of commands. I'm going to create a figure using. Did I added the Plotly Express here? No. Let me add the Plotly Express import here. There you go. I'm going to create a figure, PX, Plotly Express scatter plot with the X from X. The data frame is going to be dfpx. The Y is going to be the latitude. The size it's going to be the max oil cumulative. The color would be the oil fraction. And as a hover data, we want the well name, the max oil cumulative, and the max water cumulative. And if we run it, we should be everything running smoothly Let's see, and there you go. Here, for some reason, I think that this is being, let's call info. Why do we see that in this straight line? Because pandas, it's recognizing this column X and Y as objects. And we can, there you go, X and Y are objects. So I think that in order for us to change the data frame, the data type, it's to numeric. Yes, I think it was the to numeric function of pandas, of the property of this. Numeric. No, it's not to numeric. There, then it's pandas, and we feed this to this. There you go. Yes, it was this. It was this one. So I'm going to reset the column df px x to the numeric form. We're going to reset the y as well. There you go. And if we run it again, we should be able to see, there you go. Excellent. We have the latitude and longitude. And if we hover on these wells, we can see the well name for this. It's this well. The name is here on the hover. We have the max oil cumulative. It's X and Y, the latitude and longitude, and the oil fraction as well. We can see here the hue of the oil fraction being 1, being almost completely oil, and being close to 0, being close to high water oil ratio value. So we can kind of see the trends of how these wells behave. Maybe if we do a formation analysis of these kind of wells, we would see that maybe these wells are on that formation that has petrophysical values much different than these wells. Maybe we can develop a further analysis using the production method of that well. Maybe we are getting this water lock phenomena. I don't know. We can keep building things. We can keep doing an analysis to this. But I think that you, Kurt, that get the idea of the power and the potent things that we can get from all this analysis. So I think that give us we achieved the today's session purpose.